Then problem number 10. Here in the problem number 10, the question is find the quadratic equation such that its roots are square of sum of the roots and square of difference of the roots of equation 2x square plus 2 in bracket p plus q bracket close x plus p square plus q square is equal to 0. Find the equation such that find the equation such that its roots are square of sum of the roots. Its roots are sum of the roots sum of the roots and square of difference of the roots and square of difference of roots of equation 2x square plus 2p plus q x p square plus q square. Only p square plus q square is equal to 0. First, understand the meaning of this problem. Again, read the same problem. Find the quadratic equation such that its roots are sum of the roots and square of difference of the roots of equation 2x square plus 2 in bracket p plus q x plus p square plus q square. We have to find the new quadratic equation whose roots are square of sum of the roots. One root is the square of sum of the roots of given equation, and second root is a square of difference of the roots of the given equation. Here, first let alpha and beta are the roots of the given equation. Let alpha and beta are roots of given equation. Then, if the alpha plus beta are the roots of the given equation, then what we can write? Here we can write alpha plus beta and alpha into beta. Before this, compare this given equation with the standard form and first find out the values of A, B, C. Therefore, first find out the value of A, B, C. Compare given equation with ax square plus bx plus c is equal to 0. Then the value of A is 2. Value of B is 2p plus q, and the value of C is p square plus q square. If the alpha and beta are the roots, then we can write sum of the roots alpha plus beta the value of alpha plus beta is equal to minus b upon a. We know the value of b, that is 2p plus q, and the value of a is 2. This 2 get cancelled and we get only minus p plus q. This is the value of sum of the roots, that is alpha plus beta, given equation. Then the product of the roots, alpha into beta. Here alpha into beta is equal to c upon a. The value of c is p square plus q square, and the value of a is 2. The sum of the roots minus p plus q, and the product of the roots p square plus q square divided by 2. Then after that, here the alpha and beta are the roots of the given equation. But the next step is very important. We have to consider the roots of the desired equation. This is a given equation. Therefore, the roots of the desired equation or required equation we have to consider. Suppose alpha 1 and beta 1 are the roots of the required equation. Therefore, here let alpha 1 and beta 1 are roots of required equation. If alpha 1 and beta 1 the roots of the required equation, then the first root, alpha 1. What is alpha 1? Alpha 1 means find the quadratic equation that its roots are, one root is the square of sum of the roots. Square of sum of the roots. Square of sum of the roots means, which are the roots of the previous equation? Alpha and beta. Then sum of the square of roots. It means here alpha plus beta whole square. Sum of the alpha plus beta whole square. This is the first root, it is alpha 1. What is the first root? Sum of the square of sum of the roots. Square of sum of the roots. That is alpha plus beta whole square. And the second is square of difference of the roots. Therefore, beta 1 is square of difference of the roots, alpha minus beta. These are the new roots. Then here, if alpha 1 and beta 1 are the roots of the required equations, then we write this alpha 1 is equal to alpha plus beta whole square and beta 1 is equal to alpha minus beta whole square. Then as per the here, then sum of the roots of desired equation, here we can write alpha 1 plus beta 1 is equal to, because we have to write the desired equation. To write the desired equation, we require the sum of the roots and the product of the roots of that equation. If alpha 1 and beta 1 are the roots of the equation, new equation, then alpha 1 plus beta 1 is equal to, here we can write alpha plus beta whole square plus beta 1 is equal to alpha minus beta whole square. Write on expansion of this. Here but we know that the value of alpha plus beta minus p plus q. Therefore we can write here minus p plus q whole square plus alpha minus beta whole square. Here alpha minus beta whole square. We does not know the alpha minus beta whole square, but we can expand this here. How we can expand this? Alpha square minus 2 alpha beta plus beta square. We can expand in this way here. Alpha square. Then here we know the value of alpha plus beta. Then next step. Instead of this, you can also write here the square of this. The square of negative is always positive. Therefore, p plus q whole square. P plus q whole square. And here, what we can write? Alpha square as it is. Plus here minus 2 alpha beta. Instead of minus 2 alpha beta, we write plus 2 alpha beta. Plus beta square as it is. Here we add 2 alpha beta. Therefore we have to subtract 2 alpha beta. Therefore we can write minus 4 alpha into beta. And this is the expansion of p plus q whole square plus this is the expansion of alpha plus beta whole square and minus 4 alpha beta. Here we know the value of p plus q as it is alpha plus beta. Alpha plus beta, here we know the value, that is alpha plus beta is equal to, what is the value of alpha plus beta here? We can write according to the previous statement, that is minus p plus q. Minus p plus q whole square. Minus 4 as it is. Alpha into beta. Alpha into beta, we know the value. P square. Here we know p square plus q square whole divided by 2. Then 2 1s are 2, 2 2s are 4. When we expand this again, what we get here? Here p plus q square plus p plus q square, that is 2p plus q square. 2p plus q square. And here minus 2 p square plus q square. Write down the expansion of this 2 as it is. Here p square, the expansion is 2p square as it is plus 2pq plus q square minus 2p square minus plus minus 2q square. Write on the expansion of this and we get this statement. After that, here multiply with the 2p square. Here after multiplying with this, what we get? We get 2p square plus 4pq minus plus 2q square minus 2p square minus 2q square. We get this statement here. After multiplication, we get this 2p square, this statement, and this get cancelled, this and this get cancelled, only you get 4pq. Here after, what is the value of 4pq means alpha 1 into here alpha 1 plus beta 1. The value of alpha 1 plus beta 1, alpha 1 plus beta 1 is 4pq. Consider this is the first sum of the roots. After that, find out the product of the roots. To find the product of the roots, what we can write? We can write alpha 1 into beta 1. We know the value of alpha 1. What is the value of alpha 1 here? The value of alpha 1 is here alpha plus beta whole square. Alpha plus beta whole square. This is alpha 1. What is about the beta 1? Into alpha minus beta whole square. But we know the alpha plus beta. Here alpha plus beta write down the value of alpha plus beta. Here what is alpha plus beta, which is given, that is minus p plus q whole square. The value of alpha plus beta. Alpha minus beta whole square. We know the expansion of alpha plus beta from the previous. Here you can directly write down alpha plus beta whole square, or here directly you can write minus p minus q whole square minus p minus q whole square, according to the previous steps. Instead of this, you can also write down the expansion of this also. Here how you can write down the expansion of this? Here alpha minus beta, what we can write? Alpha plus beta whole square minus 4 alpha beta, which is used previously here. And here we can write p plus q whole square alpha plus beta, that is again we can write here p plus q whole square minus 4 into alpha into beta. 4 as it is. The value of alpha into beta, here what is the value of alpha into beta? P square plus q square whole divided by 2. Here we can write in this way. Then 2 ones are 2, 2 2s are 4. Here p plus q whole square as it is. Write down the expansion of this. P square plus q square plus 2pq minus p square minus 2p square minus 2q square. And here this p square. Therefore what we can get? p plus q whole square. Here we get minus 2p square, that is minus p square minus q square plus 2pq. Here we get this statement. After getting this statement here, what you can write? Take a minus sign common outside the bracket. Therefore, when we write the minus sign outside the bracket, what we can write? Here we can write minus as it is p plus q whole square. Then here we get p square plus q square minus 2pq. And this is the expansion of p minus q whole square. This is the expansion of p minus q whole square. Then look at here. Consider this is a plus b, this is a minus b. Here we can write here minus as it is. And here we can write p plus q, p minus q whole square. And here it means what we can write? We can write p minus q whole square. Here in this way you can write square whole square, that is minus p minus q raised to 4. We can write this statement. This is a value of alpha into beta. This is the second equation. After getting the value of alpha plus beta and alpha minus beta, here we can write on the required equation. Here how we can write on the required equation? Here one step is wrong here. What we can write here? Minus sign as it is. And here we can write p square minus q square whole square. This is the value of alpha into beta. Then required equation. The required equation is x square alpha 1 plus beta 1 x minus alpha into, here there is a minus sign and here plus sign, alpha 1 into beta 1 is equal to 0. X square as it is minus alpha 1 plus beta 1, that is 4pq, x plus alpha 1 into beta 1. Here the value is minus p square minus q square whole square. This plus minus minus, therefore the equation is x square minus 4pqx plus minus minus, and here we can write p square minus q square whole square. This is a desired equation according to the given condition is equal to 0. That is x square minus 4pqx minus p square minus q square is equal to 0.